Hey everybody. There are a variety of ways to get started learning LabVIEW. We have basically this venerated CDAC kit right here that allows you to not only use LabVIEW as a programming language, but also a great interface to hardware. Another thing that you may have been introduced to are Raspberry Pi Picos or small microcontrollers, including some of the things that the LabVIEW community itself, not even NI, has really dove into recently with something called the LabVIEW Community Training Initiative. We refer to it as CTI. There's like a LabVIEW Discord for it, or sorry, there's Discord specifically for it. There's a lot of different things going on. But in particular, one of the things that is the ethos of the community training initiative that is so valuable above and not only kind of alongside of the traditional LabVIEW hands-on CDAC kit that we have is that the idea is it should be LabVIEW anywhere for as cheap as humanly possible. And so the community has gone through and done a lot of different things, but they've really focused in on enabling the usage of this very simple device right here, if I'm not mistaken, which is a Raspberry Pi. If I can kind of get it focused in, there you go, a Raspberry Pi 2040. It's not a computer, it's not the traditional Raspberry Pi, but it's a microcontroller that has a variety of I/O, programmable I/O. It's not all that dissimilar to some of the hardware that we have here in some professional gear. But much like you could use a child's simple camera to record something versus a professional gear camera like what I'm recording with here now. Each has its place, but we know that LabVIEW connects to all of these things, and it's the best tool when it comes down to giving you the ability to quickly visualize and quickly build interfaces and also quickly connect to a variety of different things. So I want to bring you on this journey that I'm going to go through right now. I just got this kit that you may have as well, picked up off of Amazon, and it's got so many things in it. It is not just the Raspberry Pi 2040, but I wanted to record this process to see if it helps you get started trying to connect for the very first time. So let's go ahead and give it a shot. All right, so what we're seeing here is basically the setup kit that I've got. Hopefully this is coming through clean and clear, but what I'm gonna do is basically just do this live with y'all with, if you have one of these in hand, how do you get started? But there's so much stuff in here, like not only from like sensors and potentiometers, buttons, servos, this even includes a servo kit, an IR transceiver. Actually, where's the little, so yeah, there's like basically a little IR circuit board. I got this for I think under $20, maybe $17. It's straight madness how cheap this is. Now I'm hoping because I got it so cheap that the little Raspberry Pi still works. But long story short, to first connect into it, I'm just going to go ahead and we're going to find out the hard way how good of an engineer I am. I'm going to go ahead and put it into the circuit board here. I'm just going to go ahead and kind of line it up with the general pins. So just kind of got the 0 through whatever, just try to get it lined up on here, get it pushed down a little bit easy. It's usually for a very fresh breadboard, these connections can pretty tender, but this one seemed to go in pretty well. So I've got it there. USB cables. This is a very important thing to note. Not every USB cable is created equal. Now, normally that matters a lot. Like, oh, why is Apple selling their Thunderbolt cable for who knows how much right now? But it still goes back to simple cables that use something even as trivial as the USB micro. I believe that's what this one is. And so the quality of the cable, some are data cables and some are not. So basically, you should just be able to put this in. Let me go ahead and it even comes with a display, like it's more than a 7-segment display. It is what do they refer to it? Yeah, it's just an LCD. So pretty nice. There's the LAFVIN, Laughing. I don't know how you pronounce it, but in any case, that's all that you should need to do to basically get it set up the first time. And then, as you can see up here, I'm just going to go ahead and plug it into a laptop that is the same laptop that I'm going to use for the community program, or for the getting started hands-on, that uses, of course, the big kit over here. But in general, really, it should just be as simple as, actually, I'm going to go ahead and unplug my DAC, move that aside, and we're really going to plug this in. Now, one of the things to note is that if you hold down the button on there before you actually plug in the USB, then it will show up in the computer. Let me see if I can go ahead and show that screen instead. Let's go ahead and see if I can add this to the system here. And I will go ahead and I'll zoom in a little bit in just a moment. But basically what you're going to see is I'm going to go ahead and plug it in with that button on the Raspberry Pi. It's a little push button on there. And I'm going to go to this PC. And then ideally, if I do my job right here, I think I can go there. So that's a live view. And I'm going to go ahead and do that plug-in on that screen right here. Let's see what happens. And there you go, perfect. This is exactly what I was looking for. So it mounted the Raspberry Pi as a drive. Let me see if I can go ahead and hide the video. There we go. But in any case, the thing that you want to note that's probably the most important is that it launched it as a drive. Now, something that we're going to want to go ahead and do here in just a moment is show, well, what do I put on here? Well, loading firmware onto the Raspberry Pi Pico, which is so nice, all that you need to do is drag a file onto this newly mounted drive on your computer and then restart the Pico through unplugging the USB port and plugging it back in. Great getting started experience. So let's go ahead and give it a shot. All right, so what we've got here, I'm going to go ahead and just ignore the hardware for a brief moment because really we just need to get the system set up. So let's guide you through how to get started with the CTI image. One of the things that I know is, of course, use the venerable Google it. So I'll just do LabVIEW CTI. And there you go. So the very first hit, you've got the G Central Community Training Initiative. Now, there's a few different ways that you can actually get started with the CTI. One of the ways that you can actually leverage this that gets you started, the fastest, hands down, no installers really needed other than basically one installer and a virtual machine. You can download the Community Training Initiative virtual machine. I think I even have it maybe on the system if I go to downloads here. Yeah, you can see I've got a really honking large download here, 7.62 gigabytes. Is that right? Yeah, mega. Yeah, 7.6 gigabytes worth of virtual machine here, but it already has LabVIEW installed. It already has the Community Training Initiative software installed. It already has so many things installed. So it's not a bad route to go, but it is a Linux box. So if you don't like using Linux and you already have Windows and you're willing to go through the process of installing LabVIEW and other needed drivers, that's it's actually part of the route that we're going to go today. Because I am not as savvy in Linux. So if you're getting started on this, let's presume for a second, all these things map in general. And of course, there's the guide in the Community Training Initiative. Another aspect that's very important about the Community Training Initiative is that, as you may have known, the world has gone open source in a variety of different ways, and everybody loves GitHub. So if you do LabVIEW CTI GitHub, you will also see here that there is a LabVIEW Community Training Edition GitHub. So all the source code that we have, other than like the VM and whatnot, for all of the stuff that we're working with right now is present in that in the repo. So you can also get into it. And there's a Discord. I don't remember how to get to the Discord quickly from this, so I'm going to go ahead and pause and not necessarily worry about it. But we've got the Community Training Initiative. If you don't need to install that and you're going to get started with LabVIEW, one of the things that I know when you get the source from here is you go ahead and you get the firmware. Actually, I think it's in here. Yeah, the microcontroller firmware. And let's see if I can do, where is it? Let's see, that's the source. I don't think this actually has the firmware as it is. Let me go ahead and look for it real quick. All right, I'm back with you. I figured out what I had missed. I should just go to the Community Training Initiative source, go to the actual getting started with LabVIEW, and then just go to the firmware section. You'll see that there is your .uf2 file to go ahead and have this thing act right. So let's go ahead and, heck, I'm just going to download it. Let's do if I click on that, is it going to let me download? Download raw file. All right, so I'm going to download that file. I get that off the screen. Great, it is downloaded. I'm going to go ahead and take that file that is in my downloads, the UF2. Hopefully this looks like it's all still recording. I've got my UF2. I'm going to drag that down onto my Raspberry Pi. I heard a da-da-da. Hopefully maybe y'all heard that as well. And it basically Did it actually unmount it as well? Oh, it did. That's great. You don't even need to unplug it and plug it back in. Let's presume that worked for the second. We're going to find out the fun way. But right now, what we have is basically our Raspberry Pi ready to go um, to connect to. It's got custom firmware basically. We turned it into, or not we, the folks at the Community Training Initiative took a lot of effort to go ahead and make custom firmware for the Pi to make it act like a multifunction I/O device. But let's go ahead and look for, let's see, hands-on Pi 2040. Let's see. Perfect. So I have synchronized uh, their entire repo to a directory called SCC source code control on my computer, and I'm going to go to. Let's just look at the solutions because the training modules actually guide you through it. But I want to make sure that things are working as fast as possible. So let's just go ahead and look at the hello world. All right. So first things first, it's looking for the driver. Now, one thing that downloading the source code doesn't do is it doesn't put the driver in the expected location. So whether or not that's intended or not, we're not going to worry about that right now. So I'm just going to go ahead and stop this at the moment. Let's just go ahead and stop the loading. We're not going to try to load it. But one of the things I can tell you, and this is part of why I'm recording this so we can all be aligned, is go ahead and let's see, instrument drivers. Take those instrument drivers as is. Actually, I think you can even back up a level right here. You want to take that entire directory, and I'm just going to go ahead and Control C copy it. And then I'm going to go to C:/ program files. Let's go ahead and get in here tight. Program files, National Instruments, LabVIEW 2024, and then instrument lib, instr.lib. All right, so once you're there, you should be able to paste it in that directory. Looks like I've already got some of those VIs already present, so I don't need to do that copy and pasting. So let's go ahead and check that out now that it does exist. All right, I figured out what my problem was. I thought I got fancy. I removed part of the driver last time I used it. So I'm just going to go ahead and paste over all the files that are there. You can see indeed we have all the same files. It was this directory that I accidentally removed that has some key components. So let's go ahead and, now that it's in that directory, I'm going to go ahead and back up. I'm going to cancel this. I'm going to stop it. And now we're going to go ahead and just basically launch that same example again in those solutions folder. So let's go ahead and do that. Hello world. Hey, it launched, it loaded. You can see very easily on the block diagram. There's not a lot going on here. It connects to the Pi. It goes ahead and does a digital output, which if you had a, what's his name? If you had an LED connected, it would blink, or at least it would light up in this case. And then it goes ahead and, as most drivers do, closes on the other side. So I'm not going to worry about that real quick, but there's one very specific thing that you need to change in this, is that you must go through and you must point it indeed at your device. So you might say, well, what device do I have here, Norm? Well, there's a variety of things you can do. You can guess, for one, and see, it doesn't hurt to try either, very likely. There's an easy way if you right click on the start menu and go to a device manager. And once you go to device manager, you'll see that it will show the COM ports, and you'll see right here, I can guarantee you the Raspberry Pi is not an Intel active management technology device, and so therefore our serial device is showing up as COM5. So we've got that there now, and let's see what I've got. So now that I can go back, I can close this. I can change this to COM5, and without much ado, hey, look at that. We ran, everything looks good. It shows an error, but that's not really an error. If the status is a checkbox, not a red exclamation point, that means it passed. If it's bad, let me go ahead and go to the operate tool. There you go. That would be an error. When that's a checkbox, it is a warning. And so now you can see, indeed, we have basically connected as a CTI. We've got the Raspberry Pi 2040 Visa, the serial number, and the firmware version. So we're in good shape. Once again, if I had an LED on here, which I don't currently, that would show up probably on at this point. So I should feel pretty comfortable going through. You can choose to save all at this point because everything's in the right location. You should be able to go through and run the rest of the examples. Heck, you could just even open up the rest of the firmware, and you could look at, there's a digital in, digital out while loop. So you can see, hey, how does this chunk of code run? Of course, in all of these instances, you would need to, presuming you have the hardware, go ahead and modify this so that it points to your appropriate COM port. And then it will do the behavior. This should actually, look, I think it probably will, it'll turn a flashing LED and it will stop the program when the digital input went high. And how do I know that? Well, because this is an invert, that's a shift register. So basically it's true. It will send a true to the digital output, and then it will invert true to false, and the shift register will shift that around, and then it will send a false in the next iteration. And it's just on and off with a 200 millisecond delay in between. So it's not going crazy, turning this light, giving anybody epilepsy. So that is indeed the getting started experience for what you should be able to do. I'm going to go ahead and pause this for a moment. We might even break the video. I think I'm going to do this and figure out what lines I need to connect to. Actually, you know what? Let's go ahead and dive right into it, because part of what's nice about what they did in the community training initiative is with the manuals. If I open this up, it uses an free software. So once again, even if you don't have, let's see, let me go ahead and cancel this. Sorry about that. Even if you don't have any money, anybody can learn LabVIEW anywhere, as you can see here. And yeah, let's go ahead and see it was the while loop. So it's page 18. So let's go ahead and get down to the while loop. And one of the nice things is that you can see they have very specific wiring diagrams for if you have this very explicit breakout board, which I actually do have here, but I'm going to try to show you. Sorry, let's see. So there we go. Very nice little board. It has a buzzer on it, has buttons on it, has LEDs on it. So it actually limits the amount of extraneous wiring you need to do to get some of these examples plumbed out. But like I said, I'm going to hold off on that. I'm going to try to treat it a little bit more like I've got a Pi and I've got a breadboard, and maybe I have this amazing kit that has so many things built into it or kind of shipping with it. So if I were to look at, where's the while loop instructions? Anywhere, let's go here. Oh, scroll through. Sorry that you're watching this, but basically it's guiding you through the creation of all of those things. Let's get to that page 18. There we go, page 18, while loops. And that should be, yep, that's the exact same program. And there's the wiring diagram that we're looking for. We've got some GPIO 0, 1, 2, 3, 4 going to the individual LEDs. If I were to go back to that program, actually one of them should look for the button push. That's very interesting. I thought this would have taken a button. Well, let's go ahead and find out. Oh, this is not exactly the same. We've got to look for the one that has the button push in it. Let's see what we've got here. Stop. We're getting real close. Well, you know what? Let's go ahead and learn the hard way, as it was. So let's go ahead and get back in here. I'm going to go ahead and we're going to take a couple stabs at this. So it is digital out 1 and digital in 1 through 4. So I think there is on the board, well, we can look for that in just a moment. But if I were to go ahead and change this over to be COM5, and the digital out 1, I believe, is going to be that first pin. Let's go ahead and look at that from a, there you go. So the general Raspberry Pi GP0, which of course doesn't say what pin it is on here. Let me get that board. Maybe that'll help me out a little bit. Maybe we need to have these instructions also accommodated. But yeah, no, GP0 is the upper left. So I'm kind of using this board as a reference to illustrate what pin it is. So I'm going to go ahead and take one of these LEDs from my kit. We're going to go ahead and maybe I have to pause this and get my my other camera back on. We're going to go ahead and use a red one. It's the easiest. And then I'm going to go basically from there to ground. And let me use my reference again. So the third pin on the Raspberry Pi, so the first pin and the 1, 2, first, second, and third. All right, so let's see if I can go ahead and get this pulled back in here. All right, we've got it there. I'm looking at it. It's on that, you can kind of maybe, there we go. So it's going to that first pin and to the third pin. And we're going to just try to run that program. Let's see what kind of madness we get out of it. I'm going to go ahead and run that there. Hey! All right, it turned on, but it's not turning off. Oh! Because the digital in was flagged as, let's go and zoom in for that for y'all. All right, so let's go and run that again. It only runs once. So let's go ahead and I'm going to change the logic on that structure, actually. I'm going to go ahead and just change that around. And so now it's just going to keep running. Hey, there we go. And the reason that it was having that problem was because there was no, um, the digital input was being pulled high because there's nothing connected to it. There's no button, no pull down resistor, and so on. But indeed, that's all that it took to have a very simple program. Once again, drivers installed, run that program. You can looking at it in both places. And now we can see both of them there. All right, so pretty easy, all things considered. Programs are there, instructions are there, but everything's in place. Uh, Presuming you had the CTI virtual machine or the image, uh, the examples are there. You can get started. Once again, you've got a basic implementation here with minimal calls, and then a whole host of other things you can do from there, let alone from the kit that you've got, but also moving forward in terms of how else you can work with the community training initiative to learn from what we're doing. We're putting new personalities on it using different Pis, on and on and on using single board computers. So there's a really interesting storyline going right now that the community is indeed creating an ecosystem for LabVIEW for anyone, anywhere. And hopefully this is the very first step that you've got. So happy wiring, and I'll see you soon.